If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon. Hello, my name is James and I'm the Bald Engineer. How is everybody doing? We are going to, let me back up. Good morning, good afternoon, or good evening. Delete the greetings which are not appropriate for your time zone or sleeping habits, I guess. Tonight we're going to continue our work with KiCad, and just a heads up, this will be the last stream this week that I feature KiCad. I'm going to move the setup tomorrow over to the bench, and the next couple of streams are going to be stuff on the bench like soldering and whatever. All right, Geek Boy, good to see you. Int Pirate, yes, I did fix it. Thanks, Babin. Chat is more functional. Not quite where I want it yet, but we're getting there. Thomas, good to see you again. So what we're going to work on tonight, I had a different idea originally in mind, but I got to thinking, I haven't still finished my Apple IIgs project. And so I'd really like to get that done. We only have a couple pages left. And so we're just going to blow through this schematic and get this taken care of. So no PCB today, but a lot of work inside of KiCad. What do we even call it? Is it just IIgs Schema? But basically the schematic editor for KiCad. If you are not aware, I did want to mention what is this project that I'm talking about. And I totally realize I don't have a web browser up. Let me do this real quick. Let's come over here, do this, do that, and then reload this and this. All right. So now we can go to, let's see, it's a GitHub, Bald Engineer Bit Preserve. So this is actually a project I started about a year ago. And this was actually for KiCon, now I think about it, in April of last year. It's where I announced that Bit Preserve is a project where we have multiple computer systems, mostly 8-bit, but basically stuff from the 80s and 90s, a little bit before, a little bit after. And we're recreating the schematics for these computers in KiCad. And so the whole reason this happened is because I needed the schematic parts, I needed to draw a schematic in PCB of parts from an Apple IIgs motherboard, which, by the way, looks a little bit like this. Yeah, it's the 2GS. And I realized, man, it'd be really nice if the schematics were easily editable, but everything is a scanned PDF. So that's why we started Bit Preserve, so that we could preserve different schematics. Now, where we've been in the past episodes is we had a few. Yeah, of course I'm blocking the image. Come on. Maybe this would be better. Okay, now where we are is I have this multi-sheet schematic, and inside it are sheets that look something like this, where we've gone and redrawn pages of the schematic. D3 Jake, he said, tiny engineer, he can bit bang easier. Yeah, actually, on my Stream Deck, I named it Little James. So anyway, so that's what we're doing. Now, where are we getting all this from? Well, I have a copy of the technical reference manual, and it's going to be blocked mostly by the chat, but I hope you don't mind. You don't really need to be able to see this, so I don't think that's too big of a deal. But it's basically a scanned PDF of this book that goes through and has all the pages of the schematic in it. In fact, did I pick the right one? I think this is it. Yep. Just, what'd you do that for? All right. So which one should we work on today? I'm thinking IWM-4. So my trivia question for you is, do you know, in context of Apple II systems, what does IWM stand for? Okay. So I'll let you either look that up on, I was going to say look it up on YouTube, but why would you do that? I guess I meant to say Google and thought of YouTube. Wonder why that was on my mind. Let's make this a little bit smaller, and let me turn on some music. Let me know if that music is too loud. If it's too soft, that's okay too, but I just want to make sure it doesn't overpower my gorgeous, gorgeous voice. Speaking of. Okay. I don't think this is the right page. Because I had the... maybe it is. All right, so what is... oh, that doesn't zoom. This is a what? It has BA bus all over it. A sense already... okay, yeah, so this is it. Okay, cool. All right, so we're going to add a label. We're going to say BA bus 0. Do something about here. Hit W for wire. And move this over here. So the trivia question was, oh, what are you doing that for? Why? What I was going to say is, what does AddOhms stand for? I guess that actually makes it show up on the screen too, doesn't it? Copy and paste. That was a little excessive. In fact, WAS monitor. Carlos says WAS monitor. Really close. WAS is a correct word. Monitor is not correct. Okay, got that one redone. Let's copy, paste. No. Copy. This, we're going to edit this one. I think I've stumped everybody. So, the IWM stands for the Integrated WAS Machine. And what it means, or what it stands for, is when the very first disk controller that Wozniak made for the Apple II was basically, for all intents and purposes, a very sophisticated state machine made entirely with 7400 series logic. And so when they got to, I think it was the Apple IIe, I think it was the E, it had an ASIC which replaced all of that barebone, or all of that 7400 series logic with an IC, and they named the IC the Integrated WAS Machine, so IWM. And that chip can be found all the way up until it's even in the Apple II GS, which is what the page we're working on today. And it's actually one I've been wanting to get drawn up. I don't have a... well, I take that back, because originally I didn't have a specific need in mind for the IWM. But then I realized if I want to be able to access like even a virtual, like a SD card to floppy drive, I have to have an IWM to run the floppy drive. So we're going to have to add one into my portable Apple II project, which I'm hoping to finally get back to after I move. Or, with the way things are going, maybe it's maybe we'll get back to designing that here pretty soon. All right, so we're going to call this one Reset L. And it looks like it's going to go off screen, but for the moment, I'm just going to put it right here. And we'll come back to that. Since I brought it up, let me just show you real quick, because I think this is kind of cool. Here is the original card. And so there's a couple of, like I said, there's a 7400. Oh, no. Back this up. So this was the original card that that WAS made. And so it's basically just 7400 series plus a couple of ROM chips. Pretty crazy to think about this for a minute, because did I have the comparison in here? I think I took it out. Let me see if it was in the backup slides. Darn. Yeah, okay, this will work. Check this out. So on the left is a Commodore 64 drive. So it's actually the motherboard and then the whole drive assembly. The disk drive for the Commodore 64 has the same 6510 or 6502 processor, and it has RAM, and it's basically another Commodore 64, all to drive just the disk drive, whereas WAS's design was just a bunch of 7400 series logic and a couple of ROMs. And the elegance of what he did was amazing. See if you can get a signature from Wozniak and add it to the silk screen on the PCB to sit below the IWM. Actually, true story, a couple of years ago, there was the first Silicon Valley Comic-Con, and Wozniak was one of the major proponents and maybe sponsor. I think he put up some money to help make sure that it happened. And so I planned to go see his talk, and I did, and he did a really good talk. In fact, I might tell the story that he told because I still think it's kind of funny. But what I took with me in hopes that I could meet him, and I just was not ready for the amount of people that were at this event, so I didn't get a chance to meet him. But I did take the shell for my Apple II GS in my backpack, because if I got the opportunity, I wanted him to sign it. And I thought that'd be really cool, especially because the 2GS, the first like couple thousand were the Wozniak edition, which basically had a silk screen of his signature. Okay, what was this signal? This is another one. We'll draw it off page here in a little bit. Now, let me tell you the story he told, because I think it's kind of like a classic Wozniak thing. So he was talking about how him and Steve Jobs, back when they were first getting Apple going, they were talking about what did they think the future of computing would be. And this is where a lot of the talk where Jobs actually foretold like the iPad coming out, where his big thing was he wanted to see a book-sized computer that would become basically what the iPad is. And this was back in the, this might have been the very early 80s when they had this conversation. But Jobs said, or Wozniak said, well, I think we should build computers that help blind people, because wouldn't it be great if computers created this accessibility thing? And he said, you know what? We did it with the iPhone. Now people are completely blind because they're walking around like this. And I just thought it was such a funny Wozniak joke, because, that's just how he sees the world, right? I mean, he's just that kind of guy. Anyway, I need a rim shot sound effect. Move this over here. So Daniel asked, what computer do you have? You're talking about... So you mean like my normal daily driver, or what retro computers do I have? Let's take this. I'm gonna go Q3, Q3.h. I don't know why I drew it that way. So let's delete that. M to move this over, wire to draw a wire, and then there we go. Let's go ahead and add a ground. Jay Kittle, if your daily driver computer doesn't run CPM, we will judge you. Okay, so I do have a soft card for the Apple II GS. Scratch that, sorry. It's for the traditional Apple II. So I do have an Apple IIe, but it's not. It's one I bought on eBay that's not working, and I'm hoping that I'll be able to get the soft card running on that, so I can run CPM on that computer. And then I do have a couple of Commodore 128s, and those run CPM. So yeah, I was about to say I have DOSBox on my computer, but I guess DOSBox when it runs CPM, right? That wouldn't make any sense. Uh-oh. I just realized when I created this symbol, I labeled this wrong. Kelvin asks, do you fix iPhones? I do not fix iPhones, no. Not my jam. In fact, every time I've had to fix one of my phones or tablets or devices like that, I have a shop around the corner that I take them to. I also see something weird going on. Did I add a line in here at some point? There we go. All right, so what I want to do, let's I want to edit this symbol. Why can't I edit this symbol? Oh, stop moving. What am I missing? I thought I should be able to like click on it or right click. Oh, properties. Edit in library editor. Yeah, I'm not really into repairing modern equipment, modern stuff. I mean, no specific reason other than it just doesn't interest me as much. The reason I really like old classic computers like the 8-bit era stuff like the 2GS or Commodore is they're so simple that if you study the schematic, you can actually you can understand how the entire computer works. And I'm gonna get it wrong, but I think it was either Chuck Peddle or Bill Minch. So Peddle was the guy behind the early Commodore computers, and Minch, yeah, Bill Minch, he designed the 6502, and one of those two guys mentioned that back in the early 80s, basically one single person could understand how an entire computer like the Commodore or Apple II worked, from even down to the transistor level. Whereas today, it's impossible. Nobody has the knowledge to know how like say something down to the transistor level of the processor works, all the way up to all of the software that's running on it. You know, there's just, I mean, maybe there's a couple of people in the entire world that are at that level, but there's just too much stuff going on. The Commodore 128 was unique because it had both the 8502 and the Z80. Yes, it did. And did you know that when you're running the C128 at boot, so once you boot it up and you get to the ready prompt, you're running on the 6502, but there is a video by Bill Hurd, and I think it was on an 8-Bit Guy episode, but if not, if you can find it, anytime Bill's done talks that get recorded, you'll hear this story. The Z80 actually boots the system and then hands it over to the 6502, and it had to do with, I think there was a bug or something with the original PCB, and so they found a workaround where the Z80 actually boots the computer to enough to hand control over to the 6502. So I thought that was kind of interesting. It's like, yeah, it's still a 6502 machine, but it can't boot without the Z80 in it. All right, so where did that RD signal go? It looks like, so it ends up becoming our data. So let's call it that. There we go. So now we're going to need some resistors. What do we need? 1, 2, 3, 4, 5, 6, 7, 8 22 ohm resistors. And let's use R small because they're much cleaner. And let's see, this first one's going to start about here. And what I've learned is we want to label it now so that when I copy this, there's a lot less work. So let's go 22. And then I'll hit C and move this down here. I'll just kind of follow the same convention that this schematic is using. Okay. And then let's go, looks like right above this one. And this is going to be phase 3. And this is, I wonder if W is write request. I wonder what that does. I wonder if that's kind of like a, well, I almost said that out loud. I almost out loud said, I wonder if that's like a way to request to do a write. Which, Did the Z80 work like the SMC does in the modern Mac computers? No. The Z80 and the 128 was there to run CPM. And so, it's something I've never done. Maybe we'll do it on a stream. But you'd have to get the machine into CPM mode, which would switch it over to the Z80. The SMC in like a modern Mac is basically just the microcontroller that is dedicated to managing the power system. A couple other things as well. Oh, that's cool. I didn't realize the Z80 was originally supposed to be a cartridge. It's kind of a, in some ways, it's kind of an oddity that it was even put in there. SMC in this context is not self-modifying code. No, I think Apple calls it a system management controller. So the very early Macs, it was a really simple system. It just had basically some flash memory or maybe battery-backed memory. And then modern Macs, the SMC controls everything like the fans, charging, stuff like that. And so it's a system management thing. But the thing is, or the weird thing is, even to this day with modern Macs, where it has nothing to do with fixing any problems, everyone will say, well, when you're having an issue, reset your PRAM, which means tell the SMC to do a default setup. And it never fixes anything on a modern in a modern Mac because there's nothing in there that you could really, the user can really do. I mean, unless your machine is not going into charge mode, resetting the okay, never mind. I'm getting all worked up, and I don't even use Macs anymore. So, okay, let's move this guy over here. Edit this. Oh, we need to change the. We need to change. I'm going to make that invisible. We need to change the designators for these. So where are we at? Wrong one. I'm going to hover on the R, hit E, and then type 32, E, 30, oh, 33. Oh, come on. I'm not even drinking ginger ale tonight. I'm having trouble. 35, 36, 37, 38, and 39. Maybe that's why you're having trouble. You know, that's a really good point. I will take that in consideration. I've got a really early morning meeting tomorrow. So, however, if I'm at this point, I think it's going to happen. If I stream tomorrow night, then that might be a different story. I'm going to try. The reason I might not is because to get what I plan to do is after tonight, I wanted to start doing stuff on my lab bench. But to do that, I need to basically move my computer and everything over there. And getting everything moved and then getting OBS to cooperate after it moves is always a challenge because when I start using the other cameras, the setup changes. When it's at my desk, it's pretty easy. It's basically the same setup I use to do teleconferences for work. Yeah. Yeah, Geek Boy, I was gonna say, you're trying to make fun of me for having trouble, and look at what happened to you, see? Ships and glass houses shouldn't use screen doors. All right. Really? That's weird. I guess that is J8. Okay. That is not how I was going to label these, and it turned out it looks like they're correct. So 21 and 22 are going to chassis ground. That's interesting. I don't need, what is this connector? Oh, hello. This is oh, I didn't realize the chip that we're working on is the IWM. So this is going to the floppy drive connector. Is it? No, because that's only 19 pins. So maybe 20 and 21 are connected to the shield, which is why it's chassis ground. Interesting. All right, let's go our data on this one so that I can copy and paste these. Kill that. And then we'll M to move that over to there. So then we got 11, 12, so 13. Okay, that's not right. 10 is not supposed to have a connection, and 9 is supposed to be on 9. Huh. Fancy. And so 8 and 7 are connected together, not 6 and 7. And then 6 is plus 5, 4 is negative 12. Nope. Nice try. 4 goes somewhere else. It goes to 3.5. It says ick. So let's go. We will just go wire because it's not named again, and I don't know what else to call it, but we'll just do that for the moment. And we'll come back and do that later. Let's go ahead and get now. So that should be 9, and then 10 goes off to sense. So let's get that taken care of. Oh, I never named it. Beautiful. Okay, and now 9. Now we can name these nice and clean, and everybody's happy. There would be much rejoicing. That's what I need, is the Monty Python, yay. Yay. Yes, plus 12. Let's add that. El Rotato. Aw, come on. That's fine. And then we need a plus 5. Let's be faster to just grab this one. Rotate that a couple times. And then we want, oh, wrong place. Negative 12. We need to put the 5 here and the negative 12 here, correct? 12 plus 5, 12. Yeah. Yeah, I think KiCad running on Apple II would be a pretty amazing feat. I have considered, well, actually, okay, now I have to rethink what I was about to say, because originally I thought about trying to write like a Spice type simulator and maybe have a schematic editor or something on the Apple II. And it turns out there is a Spice simulator, and it's entirely text-based, which doesn't surprise me. And so I don't think an Apple II could do it, but a 2GS, it should be possible to make a graphical simulator. It would just have to be somebody way more talented than I am. All right. Okay, so that connector is ground, ground, ground. Negative 12, 5, plus 12. 9, 11, 12, 13, 14, 15, 16, 17, 19, R da and sense. Okay, now, let's see. WDAT goes through R32, and then that connects to J189. Okay. And to make the people that only like to see connection, or we'll do that. 33 goes to J815. All right. and 34 goes to 14. $35 goes up into number 13. Okay, 36 goes to 12. Well, that's... I'm not gonna like this. Lame. I hate doing that kind of stuff. PO0 is... $11. And then let's go. Yeah, I was just about to say, guys, how many people like this mess of wires better than just using labels to identify where everything's connected? Because now that I've done this, I don't think this is readable at all. I mean, labels for the win. Do you have an example of the alternative? So the yeah, actually I do have an example of the alternative. Good question, D3 Jake. So if we go and look at the slots, so here's what my label-based slots look like. And basically what it is there's 7 slots in the 2GS, and so with the exception of like some enable signals, these are basically all on a big bus, right? And so in a couple of cases, I did do from slot to slot just because it's pretty clean, but I think that's pretty clean to look at. And if we go look at this schematic, so let's go 50%. Here's what the schematic looks like. And so I've heard people, and even when I presented this idea at KiCad, people were telling me that they prefer this up here instead of that over there. Oh man, just a little bit. That over there. And I just think that this is much better. And so my feeling is that this version is probably more readable if you're using paper, or even if you only have a PDF. But my point was, for this project, the whole idea was to actually get to have the schematics in a CAD tool so that if you wanted to look up where these individual wires go, you could easily do like searching or highlight or something like that. So the more and more I talk, the more I realize we're not going to do it this way, because it looks terrible. I don't like it. You guys don't like it. So we'll do it that way. Although I should have probably left it until I was done, because what I can probably do is, can't I just, oh, I thought it was going to tell me the name of the node. Is there a way, like, if this were Eagle, it would know the name. And if I hit highlight net, no, it doesn't give me the name. But this makes it a heck of a lot easier to read. So what we can do is, okay, we're going to do something like this, and then we'll delete that. There we go. This might work, assuming I connected these correctly the first time. Delete that, redraw that one, and redraw that one. Yeah, this is, I just like this so much better already. Kill that and kill that. Highlight this, kill that. And then we can come over and do this. $814. Let's do this. Delete that one. Wire to here. And then delete this and delete that and wire to here. Beautiful. Look at that. Oh, this is so much better. So much better. Go. All right. Don't really need to highlight that, do we? Beautiful. All right. That is much better. My only other thought is, should I line these up so that these are all justified to the same place? Or maybe not, because that sort of implies that it's a one-to-one connection. And this way, I think it's more clear that they're not. Wilmer says, the European style resistors are ugly. Okay, well, you know, some people, they're just hard to please. I actually like the European style resistor better than the American style. You know, despite that. Despite that. Yeah, I started using, frankly what happened is, so when I'm doing animations, like the video animations, the US style is just a lot easier since it's a single box. And because I started using them so much, I got to a point where I just visually, I like them better now. So that's the story of that nobody asked me about. Let's copy this. We'll do that. Copy this. Copy this. I do this every single time I do these because I want to turn this off. And then let's go ahead and put the first set of numbers in here. Michael pointed out that I have a green soda can. That's awesome. Yep. I guess I'm one of those guys now. Oh, why didn't the designator copy? That's dumb. Okay. Chris asks, why don't they just put the resistors inside the IC? Well, in modern ICs, you will find a lot of things like these series current limiting resistors. But the problem with it is resistors are really big and they take up a ton of space, and that makes it really expensive. And so it's hard to justify. And so when you go back to the 80s, when this stuff was being built, they simply did not have the space on the silicon to put a resistor. Instead, they would rather save the space for transistors. Also, resistors created heat, which back then, yeah, as Geek Boy just said, you're dealing with more heat to dissipate, so it just doesn't make as much sense. Now, here's the cool thing, and if I had a picture of it, I would show it to you, but I'd have to go find it. You don't normally actually put a resistor into an IC. So sometimes you'll see like this, you'll see these like zigzag patterns on the die, and that could be a resistor, and that's usually if they want to laser trim it to a certain value. But the other way they do it is basically just put a if it's a CMOS process, they just do a MOSFET, and it's basically the resistance between the drain and source, I think. Now that I said that out loud, I might have the process wrong. But the point is that like a pull-up resistor is actually just a transistor because it's a lot smaller than a resistor. However, it's much harder to control the resistance. But for a pull-up, you don't care what the value is. So that's why they get used. Anyway. That is not where that one goes. 162 goes to WREC. And then 161 goes to WDAT. Do onboard resistors generate more heat, causing another concern for spacing? I wouldn't say they generate more heat, they just generate heat. You know, and especially like if it's a pull-up or something, it's not going to be a lot of current. But when you're just, you know, basically with IC, when an IC is designed or manufactured, the goal is to keep it as cool as possible. And so any additional heat sources are not usually preferred. So yep. Okay. Are we going to get super lucky and have those go to the exact right place? Nope. Not even close. No problem. Barely an inconvenience at all. Okay. Delete that. Rotate. So these are spaced out a lot differently. I wonder why. As a young engineer, I once tried to measure a pull-up resistor inside of an IC with a multimeter. Oh, good times. So let me think about that for a second. Why wouldn't that work? Unless the chip was powered. I don't know that you're going to actually get the pull-up resistor measurement, especially if it's an open transistor. But I think you should be able to. Yeah. Oh, no. I guess you really couldn't, because how would it be connected to the pin when there's no power? Yeah, so that wouldn't work at all, would it? I was thinking you would end up, because you know what you're going to end up measuring is you're going to measure whatever the protection diode on the pin is. That's going to get activated when it's powered off. I don't know if this story will translate, but I'll tell it anyway. So when I was early in my career, I was an application engineer at an oscilloscope company. And we came out with these really cool differential probes. And they were designed for high bandwidth measurements. So the probes themselves were on the order of, this version was either 6 or 12 gigahertz. I can't remember which family. And so an engineer called me and said, hey, I'm using your probes and they're terrible. You need to come and pick this scope up because we're returning it. So I went out to his lab to see what he was doing. And he said, I'm measuring pull-up resistors. And since we spent all this money on this new, it was a 6 gig, this new 6 gig scope with these fancy 6 gig probes, we're using those. I'm like, okay, so you're using a 6 gigahertz probe for a DC measurement. That's brilliant. And he showed me that when he connected his DMM, he got, how was he verifying? So he was verifying with the voltage. So he would connect his DMM and he'd see that the pull-up was 3.295 volts, which is what he expected. but then he would connect the $8,000 probe and it would measure 2.78 volts or something. And so he was like, we got to return it. You can't measure DC. This thing is crap. It's terrible. Well, what he didn't realize is his pull-up resistors were all at least 10K. And the input impedance of a multimeter is what? A mega ohm? I think some might be 10 mega ohms, but it's huge. The input resistance of this 6 gigahertz high bandwidth probe at DC was like 100K. And so I did the math where I showed him what the voltage would be with a 10K and 100K resistor in parallel with each other. Not the most difficult math. And he goes, well, that's BS. Your scope just doesn't work. I'm like, well, I don't know how to argue with you now because I just proved with this thing called math that it's working correctly. In fact, we could predict exactly what he would measure on every single thing. And he's like, well, if your scope can't do it, but a DMM can, it must be terrible. I'm like, I think there's something wrong in this picture and it's nothing to do with my scope. Math is hard, remember? Okay, those are looking good. These are over here. These are over here. Okay, I'm happy with that. We need to take care of, what's up here? What do we got going on? Field value. Okay, that can stay. Yeah, I need the other one. What's the reference? That should come over here. Hey, Jose. You are a KiCad master. Far from it. Far from it. Although, I did get a chance to see Pitor on from 1Bit Squared doing a KiCad or a PCB today. And he wasn't... He was pleasantly frustrated with a small little bug that he ran into with the way that focus happens. But it was very gratifying for me to see somebody who's significantly better at using KiCad than I am struggling with a little bit of a quirk. Because sometimes I feel like it's just like, gosh, after how many hundreds or thousands of hours, I still can't get these simple things sometimes. And yeah, it was just nice to see that everybody struggles a little bit sometimes. Which I know some people are going to be quick to be like, haha, see, told you KiCad sucks, it has bugs. But the thing is, all CAD programs, especially all ECAD programs, have usability things. I mean, you have to remember, like, especially ECAD, there are very few people who understand electronics and can write software on the level that you need to write for an ECAD program. And so, sometimes things don't get done correctly or the resources are limited and whatever. So I would never throw a stone in a glass house and say, oh, well, Eagle has far more bugs than KiCad. I mean, that's a stupid. Anyway, I'm being defensive before I need to be. All I meant to say is that it was nice to see that I'm not the only person that struggles with KiCad sometimes. Let's put him here, bring this up here. One of the reasons I love watching streams like this is you get to see warts and all. Yep, you get to see the silly mistakes that people do. Yeah, actually, one of the reasons I remember a long time ago, when I wanted to do more streams, one of my goals was to do KiCad stuff. And it's because when I made that 3 series episodes on how to design a Arduino board, I was trying to walk a really fine line between what are the things to include to show if you design your own, but also show just enough of KiCad that you could follow what I did, but I didn't want it to become a KiCad tutorial, which also meant I sort of had to edit around some issues I would run into because I didn't want to get bogged down and lost in, oh, well, KiCad does it this way, so we have to do this, or this is the 5th time I did this because that button kept crashing. That kind of thing. All right, let's get this up here. 3.5 IIg. Yeah. That's gonna make me laugh every time I look at it. We'll go ahead and do it that way for now. Yeah, I don't like that. We're just gonna do this. Thank you for the follow. And if I missed anyone else that's followed earlier, I apologize. I can't actually see the notifications on my screen. Psycho asks, what are you doing creating an Apple II yourself? So right now I'm just recreating the Apple II schematic. This is part of a bigger project called Bit Preserve. And it's actually a project where we went through and looked at, or where we are recreating schematics for classic or vintage computers in KiCad. So we're taking the scanned PDF files or even scanned hand drawings that some of these computer systems have and putting them into KiCad. And so I'm working on the Apple II GS. And the reason I'm doing it is because I plan to build a portable Apple II, which is what kicked this whole thing off, because I needed the schematic to do some work. And I was like, man, it wouldn't take much effort just to redo the whole thing. And then here we are a year later, still doing it. In fairness, I haven't devoted a lot of time to this project, so that's my own fault. But it's pretty fun. And in fact, I don't know, there's probably been maybe something like 10 contributors. I've kind of lost track at this point. How many people have contributed? 7 contributors to the Bit Preserve. A couple guys, I think his name was Robert Bosch, or his last name was close to Bosch. He did a lot of the early work. I was really impressed with him. He was adding a new schematic almost every week for a couple of weeks in a row. It was really impressive. Do this, and then we'll do that. And this is TP. Hello, edit, please. TP27. Your DIY Arduino PCB series is one of my favorites because it had a mistake, included some hardware debugging. Yep. Yeah, that one, I think I've talked about this before on that Arduino PCB series. I designed the board intentionally with a bug, and I thought people might even catch it in the video and then say something. And then when I got the original boards back, or maybe it was, I might have caught it before I sent the boards off to Osh Park, but I ended up realizing there were, yeah, that's what it was. I fixed another bug, and then when I got the boards back, I found yet another bug. So I had to spin the boards again to get a functional board, but did I? Or maybe I did fix the boards and then I ordered new ones, but in the video I showed the one where I actually had to fix it, and that was actually a true mistake. I had to fix those mistakes. Is there a train in the background? Yes, I have my windows open and I live about a 10-minute walk from the train station. Which is funny because I was actually noticing today when I went for my daily walk that it sits at the station for much longer than it used to because it's running ahead of schedule. All right, F clock, I think I messed up. I did. So Q3, what did I do here? So BA bus goes 0, 1, 2, 3, 0, 1, 2, 3. MD bus goes 0, 1, 2, 3, 4, 5, 6, 7. Oh, crap. Ah. Okay, I made a mistake. See if anyone picks up on it. But what I noticed is Q3.h should be connected to Q3, and it's down here. And I see why. See if anyone else does. Did you have an Apple II yourself when you were younger? I did not. So let's see. When I was very young, I want to say 4 or 5, my brother, who was 10 years older than me, he had a VIC-20. And my best friend at the time had a Commodore 64. And young James, young before I was even close to thinking about being an engineer, James, could not figure out the difference between the two, except that I wasn't allowed to touch my brothers, and Gregory's could run something called Print Shop. And then it wasn't until I don't know, man, it must have been like 1990 or something, that my family could finally afford a 386. And so all of the computer work I did was basically stuff I did at school. And so part of why I wanted an Apple II in my personal computing collection was I was in elementary school, 4th or 5th grade, and I would figure out how to spend the long recess every other day to go and play with the Apple II, with the Apple II GS. And so it was my favorite computer, and I dreamed of owning one day. So that's actually why I have one now. And Tisboyo wins. I skipped D6 on the chip. Shoot. So I think we'll be able to fix this. I think we can fix this. So 386 was decent material in 90. So when we bought our 386, it was a couple $100 cheaper than a 486. Maybe it was even $500. Maybe it wasn't as small as I'm thinking, but the difference was small enough that we could have afforded to buy the 486. But at the time, as a kid, I didn't know the difference between the two chips. And the reason we ended up with the 386 is because, and this is such a dumb reason, but I didn't know any better. The 386 had a fax modem, and the 486 only had a regular modem. And I knew that fax modem meant it could do more. So I was like, well, it can do more and it costs less, so we should get the 386. And so we had a 386. It was a SX chip, which in the 386s, the SX didn't have a math coprocessor and the DX did, whereas the 46 DX actually didn't mean anything. Somebody in chat will probably know there was like one really minor difference on the 46, but on the 386, it was a big difference. It was 16 megahertz, but it did have VGA graphics. The thing it didn't have, and we never got for it, was a sound card. And that was rough. I didn't have a sound card until my senior year of high school. Maybe even when I went to college, because I built a computer with money my aunt gave me. It was a Pentium 233 with MMX. And that was the first time I got a sound card. You don't know the difference between a fax modem and a modem. So it's actually not that big of a difference. I don't even know why there would have been a hardware difference at the time. But basically, the internal modems came in two variants. Some could act as a fax machine, and some couldn't. And offhand, I don't even know why it was the case. Oh, okay, I got them backwards. That's right. So the 386 SX, it would actually become a 16-bit data bus with the DX, and then the 46, it was just whether the coprocessor was there. Okay, my bad. Yeah, cool. See, I knew somebody in chat would know. That's so cool. All right, let's get this fixed. Let's go into library editor, and we're just gonna move this one down, and let's move this one down, and this one, and this one, and then we will add a pin, and it's going to be D6. Let's come back to the pin number, because I just realized I don't know what it's supposed to be. It is not supposed to be inverted. And that doesn't fit at all, does it? Yikes. Oh, man. Okay, that looks a little better. But what I'm worried about are these pin numbers. So let's go back to the original schematic and see how bad this is. So 3, it should end on 23. Before is 24, 25, 18, 17. Awesome. Awesome. We just got to do a 17 and it looks good. Since we're here, let's double check this other side. So sense is 21, RD 22, 8, 9, 27, 2, 28, 1, 20, and 19. 14 for ground. Okay, cool. Save that. Close that. And all right. And younger you was keen on faxing. You know, thinking back with that computer and that modem, I don't think we ever sent a fax. And the only time I can think of sending a fax before my professional job, before I got out of college, was I had a Connor hard drive. Western Digital had acquired Connor, and there was a problem with the Connor, so I had to do a warranty repair, and they basically made me fax a copy of my receipt or something, and then they sent me a check. And I remember having to use my fax modem to send that fax. I'm just going to leave you guys to discuss the 386, 46 thing. Yeah, those and what's so bad is then Western Digital went on with that. They kept that division around, and I think that's where they did the Bigfoot drive, and those things were freaking terrible. I mean, they just died all the time. Okay, so so here's where I got messed up. So reset, and then init, or that's probably internet device 6. And then F clock is going to go to 7MH. All right, so now we can put these back. Wire to here, and then copy to here. And we'll label this is going to be 7M.H. Oh, Steve, I'm jealous. I want it. I remember because I think it was Computer Shopper. I would buy about, I was gonna say once a month, but I don't even know how often it came out. Maybe it only came out once a month. But I remember seeing those AMD 386DX like backpack things that would plug into the socket, and I just dreamed of being able to do that. Jason, I'm very jealous that you have a Bigfoot that survived. I bought 3 or 4 of them. Now, granted, I did buy them from like some kind of auction site that was new. It was like in 97 or 98, and they were selling refurb drives, and I got them for like $20 or $30 each, which in retrospect probably meant they were warranty returns that got scrapped, and then somebody was reselling them because every one of them that I had died. Okay. I did just realize something. I'm going to come back to that later. Q3 init HD select. That's just going to be easier to copy and paste this. So that's going to be 153 HD cell high. Copy that, edit this. And then we'll use a 470 ohm resistor. Just got to add ohms. And that's going to go to JA16. All right. Not JA, J8. Silly rabbit. And just a reminder, if you're not familiar with KiCad, if you use your if you use your middle mouse button, it makes it easy to pan around the schematic. $100 for a mega RAM. Yeah, actually my 386, it came with 2 megs of RAM. And I remember when I got, I had like a couple of paper routes and and then a job washing dishes for a while. And I remember saving up to get, I was trying to save up $250 for a 2 meg RAM upgrade, and it went on sale for $199. And I was so excited that I would finally have enough RAM to use desk view so that I could crash 2 programs at the same time. I mean, it is crazy to like think back to, like if you think about the Commodore 64 and it runs something like GEOS, and you look at the kind of the stuff you can do in there, and that's pretty amazing what you can do with 64K, but very few people use GEOS on a Commodore 64. But a lot of us around my age, we had x86 computers, like a 2 or 3 or 486 with 1 to 4 megs of RAM. And especially what I was going to say is the ones with 1 to 2 megs of RAM, it's really amazing to look back and realize what we were doing with those machines, because it's not incredibly different from what we do today, but everyone has gigs of RAM available. I mean, even modern phones, right? They're 2-3 gigs of RAM. Yet we used to be able to get all of our computing done, even Windows-based stuff, with 2 to 4 megabytes. Most of the stuff Quarterdeck wrote was amazing. It was, and actually, I think it was something about like having the low-end SX processor. Desk view didn't work as well. There was something about my computer configuration that it was not a recommended config, and I don't remember what it was. It wasn't just the RAM, but if you had a good machine, desk view was actually pretty functional. Dreamer, was that a Pentium, like a Pentium 100, or was that like a Pentium 2? And sort of how I differentiate when I think about like 2 megs of RAM versus computers that started to have 10 megs. At that point, RAM started to become relatively cheap, and so it wasn't that hard to add on. But I mean, really, if you think about it, what we were doing with machines with 10 megs of RAM is probably very similar to what we do today, just with more with more pixels. Hey, Pitor. Yeah, I fixed the chat today. I got some inspiration when I saw your stream. I was like, what if I did it like him? All right. Okay. I want to go and work on this bad boy for a little bit. Let's see. So what is this? This is the 8530. So the first thing we're going to double check is, did I get the pin out right? So 8, 9, 6, 40, 41, 38, 23, 13, 12, 39, 37, 1, 2, 44, 3, 43, 4, 42, 5, 32, 27, 26, 29, 24, 30, 25, 31, 19, 20, 16, 15, 21, 22, 14, 36, 35, and 10. Okay. Yeah, I really wanted the chat to be like right next to me and down here, but playing around with it, I really didn't like it. And when I saw like how yours disappeared over time, I really liked that. And so I don't know, I think it works because I do like, especially since I'm combining multiple streams into one, I want to make sure everybody can see what somebody else is saying at some point. But I also don't want to just clutter the screen with chat, especially when we're doing stuff like this where you sort of need to see what's, right there. Or it's nice if you can see what's right there. I guess you don't have to see it. Okay, IEI, init ACK, init, read write, select, clock, retex, sync, AC, D12345670, D12345670, 0, receive, DTR. I wonder what this chip does. RTSB, TX, DCD, TRX, CTS, RxDB, DTR, RecA, Retessa, TextDA, TRX, CA, because this looks like, I wonder if this is just a smudge. No, it is, because this is TXDA, that's TRXCA, CTSA, DCDA, RxDA. Okay. Excuse me. Okay. IEI, okay. Int ACK. Yeah, so I'm actually streaming on YouTube, Twitch, Facebook, and then I also have a Discord channel, although most people don't chat too much in the Discord while I'm streaming. And then I just thought it'd be better to bring them all the chats together so people on Twitch and YouTube can see each other, because actually about half the people watching are on each of them right now. So, okay, let's start with MD bus because I can just copy and paste those. So let's do that. I think I picked up a BA bus. I did. Oh, in fact, I could have copied those over too. And that's going to start at D0. And then, yep, so MD is basically, okay, missed that one. Delete this guy. Okay. And then I need BA bus 1 and 2. We're just going to copy and we're just going to retype those. It's not worth moving all over the schematic for that. BA bus 0 and edit BA bus 1. And so 0, 1, 2, 3, 4, 5, 6, 7. And that ends up on sync A. Okay. Let's add a ground. And we'll do that. Wire this. And come on. There we go. Is this the original 2GS? So this is ROM 3, which is the third revision, which is probably the most popular. I think there was ROM 0, which is which most of those were the WAS edition. ROM 1, I don't think ever got released, and then this is ROM 3. I don't recall the differences if there were differences in the PCB. I mean, the name sort of suggests there was a different ROM, but I feel like there was at least one hardware fix in 3, but I don't remember anymore. It's been a while since I read the tech manual. The book that I got the schematics from has the differences in it. I just don't remember what it was. There we go. All right. Tux asks, are all the chips needed to build one? Nope. In fact, so ultimately my plan is to make a portable Apple II, and the trick I'm going to employ is on the Apple II GS motherboard is, let's go back to the motherboard. So this is the motherboard for the Apple II GS, and just for comparison, here was the logic board for the Apple II, the original Apple II. And so if you were to actually look through this, with the exception of the keyboard controller and the ROM chips, everything on here is an off-the-shelf chip. And so when they started designing the 2E, then the 2C, they started to create ASICs which combined some of these chips until they got to the Apple II GS, which has a chip called the Mega 2, which I think is this one. Yep, it's this big chip here. And the Mega 2 is all of the logic chips you saw on the other board, and I think I counted 78 logic chips, are integrated into this single IC. Now, what this doesn't include is the processor, RAM, or ROM. And so if you take this chip, a 6502, ROM, RAM, and let's see, an IWAS, or the IWM, the disk drive controller, and then the video graphics chip, which are basically, it's this one. I think IWM is one of these over here. You end up with enough hardware to build a functional Apple II. And so a friend of mine who used to do lots of videos with retro computers and building portable systems had a spare 2GS, which was somewhat in pieces. And so I have the remains of an Apple II GS, so I'm not destroying a functional computer. And I'm going to use it to take this Mega 2 chip out, plus the other ones, a couple of the other ones, to build a portable Apple II, since it won't require all of the other chips. So just to be clear, this is not going to be a portable 2GS. It'll be a portable Apple II. The 2GS, I mean, to make this portable, you basically cut this off about halfway down, and then it's all of this stuff, which isn't impossible. But one thing I definitely don't want to do is I don't want to cut up the PCBs. I don't mind removing the chips and desoldering them because I know how to do that safely, and I most likely won't damage them. But I hate projects that cut up the original PCBs because I feel like that could still be useful to somebody at some point. So my project is going to use a couple of the chips on a custom PCB, and then like I said, I'm only going for Apple II compatibility. I'm not trying to make it a 2GS. And frankly, part of the reason why, there's just not a lot of 2GS software that's really out there. You know, the 2GS suffered the same problem that the Commodore 128 did, which is it had all kinds of new and cool capabilities that nobody took advantage of because they wanted it, everyone that wrote software wanted it to be compatible with the existing and the new computer. So how do you do that? You just keep it in compatibility mode. And that's kind of a bummer because the 2GS was a really awesome machine for the time. Anyway, let's get this going. So where does this guy go? We got that one, The sync, let's see, 12. Looks like it connects to 32, and 32 connects to something called, is that UE? It must be UE. I haven't made that yet, so we're gonna take a guess that we'll come to it later. And it looks like that's gonna connect up around like this. I keep forgetting that the middle mouse button doesn't move the PDF. I think I'm on a different page now. Yep. All right. Let's go to about 150. Move this over to about here, and then let's give ourselves more room in KiCad. Retro machines are getting a surge of new software developed for them these days. Yes, they are. Even actually, Nintendo NESs. I think I now have 6 cartridges I've bought over the last 2 years or so on, I say bought, but they're all projects I backed on Kickstarter. With the exception of maybe one of them, they're all really good. And then there's a Ultima-like tile-based RPG that's in development for the Apple II. I think it's called Nox Arcana. I might have the second word, but it's Nox Arcana, something like that. And my hope was I would have my portable Apple II done before that game comes out. I don't think that's going to happen at this point, but I'm pretty excited about that. I think that'll be fun. They've even talked about making a 2GS version of that game, which would be super cool. And it makes me really glad I have a 2GS that I can use for parts, and I don't have to tear apart my real 2GS. So that's pretty cool. So what kind of what kind of game was the one that you backed yesterday? Yeah, to be fair, oh yeah, I just saw your comment about, yeah, actually, I mean, you're totally right. Like if somebody, I feel like I'd be surprised if people weren't making 2GS software today, just because, I mean, why wouldn't you? Never mind, I don't want to get into all that. RTCXLA comes down here, okay. And then for some reason, this one is labeled UE1513. That's interesting. Is this, wait, am I, okay, so this is UF13. What is UE? That's a C. That's a C. And the connector, that's VD. Or I guess that's UD. That looks really like a V though. That's gotta be a U. I don't know where this is going. I almost wonder if these are labeled wrong, because these are labeled UEF1538. So shouldn't this be UF1313? Huh. Extended user port. See, this is okay. You know, well, of course, it's right there. I wonder. Okay, I'm gonna take a note because I'm not gonna solve this tonight, but why does original schematic UF13 have pins labeled UE15? Because they're all labeled UE15. I have a thought. I wonder. Excuse me for a moment while I think through this. Hold on. I need to look up something. I think I have the full PDF of this book, and I think it has a bill of materials. So I want to see real quick. Because I'm just wondering if there's a bomb, then I can take a look at that and find out if it's a typo. Shoot, I don't have the full book. Okay, I'll look that up later. so is the Icebreaker NES just your Icebreaker, or is that the same hardware, just a different bit stream, or is it different hardware? Oh, Trophy. Yeah. Yeah, I backed that one as well. That one looks really good. I mean, all of the homebrew I've done so far, I've enjoyed, with the exception of, like I said, one game, and it's not really my style of game, so it's well made. I don't really like playing that kind, but Trophy looks really good. I'm really excited about that one. Okay, and actually, I think I've gotten lucky with like retro games on Kickstarter, but they are sort of the thing that it's frustrating when people are when people say, "Oh, all Kickstarters are crap," and it's like, well, if the thing is something like a retro video game where you get physical copies made. To me, that's where like something like any kind of crowdfunding is a fantastic vehicle, because then you can figure out, how much is it going to cost to actually produce it, how many should you make, and all that stuff. And it doesn't take a lot to look at a Kickstarter and say, okay, is this game done or not? And if it's not, then you don't back it. But I think people get burned on crappy Kickstarters and don't realize that there's actually a functional value to it. And I think, how many things get done through crowd supply that are fantastic products that we wouldn't probably have if it wasn't for crowdfunding. That was a slight plug for you, man. For you to mention, oh, I use crowd supply. I think you use crowd supply. What type of engineer are you? A bald one. Sorry. That seemed a lot funnier in my head than it probably was. I have an electrical engineering background, or electronics. The degree is electrical engineering, but I try to differentiate because I don't know how to do like electrical wiring. I can do basic stuff, but I would still hire an electrician, so to speak. TP70 comes into read. All right. Read. We'll come up to here. That looks like a good spot. That's going to be 71. Dr. J, if you think you've got a better schematic, feel free to send it my way. If you have trouble finding contact info, let me know. Probably the best way is to drop me a line on Twitter or join the Discord and send me a link there. But this one came out of the technical reference manual, and so what I don't know is if there was something published after that. So, that's part of the problem with these like book-based schematics, right? They didn't get a whole lot of additions. So if there were mistakes, it might be hard to find. Or it might be hard to find the corrections. Okay, so I see what they're doing. This ends up getting labeled 40. This is 41. Select the label. Let's go 40. Edit this one. Yeah, I sort of, I don't want to say this. I don't want to say this out loud, but I'm going to because I already started. If I see something I find interesting on crowd supply, regardless of where its pledge goal is at, I will place an order. Whereas like with a Kickstarter, even if it's a retro video game, unless somebody else has sort of promoted it as knowing the creator, I might wait till it gets to a certain critical mass before I finally decide to back it. But on crowd supply, if there's something there that I think is interesting, I will back it. even if it's not looking too popular, because I just feel like they have a pretty decent vetting process, and so far everything I've gotten from there has worked out well. Zap Rebel. I browse Kickstarter when I want to feel better about myself. Well, there's also that. There's a lot of junk as well. CREF-H. Looks like CREF-H comes into here. If you really, I mean, I'm sure there's been good stuff on it, but if you really want to feel better about yourself, go look at some of the ridiculous projects that end up on Indiegogo. I don't know that I've ever backed anything on Indiegogo, and I don't think I ever will. That just seems like, no. Just no. I mean, no. That is not a good idea. All right. I'm sort of avoiding these logic gates because they're not all that fun to draw. What? What is a LS51? Oh, that's exactly what the schematic is. So it's a 2 input and or invert gate. Totally. I can't believe I didn't catch that right away. Yeah, Zap, your comment about the regulatory approvals, I totally agree. I think when I see crappy projects, that's usually where I start to get nervous when people, you know, you'll see their production schedules. It's like, oh, we'll have a prototype in August and we'll start shipping in September. And it's like, yeah, I mean, I've seen stats that are a little bit ridiculous, but they'll say like 80% of most, or 80% of digital projects fail EMI testing. And so, you know, maybe it's a minor thing. Maybe you add a ferrite or something, or maybe you just have to close off a case or something. You know, it could be a minor repair, but there's still going to be some cycle time in there for you to take your prototype, get it, test it, and then do something with it. And people always seem to overlook that as if it's like, oh, well, it's no big deal. We'll get that check marked. It's like, no, that's... I mean, if you have a really solid design with a lot of experience, then yeah, you probably will get passed through most regulatory things on the first try. But that also means you're doing a bunch of in-house testing to make sure you pass it on the first try. So, well, enough of my ranting. So what we need, I just realized I never put this in the schematic, is we need this 74, I wonder if we have one, a 74 LS51. It does exist. How about that? Now, why don't I have... Where did my columns go? Okay. So what do we want? This one or this one? I bet we want... Is this something where it's like... Oh, I see. So that's what... Is this like A and this is B? Yeah, okay. So this is the same chip. And oh, nope, that's going to be this one down here. And then what we need to add is, oh, there they are. Yeah, that's what I was looking for. So yes, that was unit. Oh, this is weird. So these are backwards. I don't think this really matters as long as the pinouts are the same. But A and B are switched on the units. Thanks for the follow. Sorry I missed your name. Hey, RJ, good to see you back, man. Rant triggered. Yeah. Yeah, I try not to. Or at least try to catch myself when I start getting too far off, because I just don't want to be that guy. Anyone that knows me knows I have some strong opinions about certain things, so I don't know what I just hit. We're going to save because I don't know what I did. Oh, I hit S, that's why. So let's do that. Okay, so A, B. Do I have to do something? Okay, Dr. J, thanks for the link. I'll check it out afterwards. Hey, Derek. Do I need to do something to tell KiCad that these are the same unit, or when it goes to annotate? Wait, never mind. I forgot we're not going to let it annotate. Okay. 6, 8, and then we'll figure out where all these go. So test point 73 connects to everything, or it looks like it connects to everything. We're going to need some more space, so let's move all this stuff down. The question I was going to ask on these, what are they called, multi or split parts or multi-part or multi-units? If I was going to let KiCad do the, if I was going to let it annotate it automatically, how would it know that I wanted these two to come out of the same package? Or yeah, I guess it doesn't really matter for the moment. That's what I was getting stuck on, is how do I know that, how do I keep these two connected? Or would I just go back and modify that later? Okay, so it's geographic. Yeah, okay. I guess that's what makes sense. It's just not something that I've actually done. Or have I? I feel like now that I said that out loud, I feel like I did a schematic with an op amp. And I had to deal with that. Because it was like a dual package. Yep, nope, don't like that. Let's flip this. X. No, still don't like that. So that gets me pretty close. Okay, we can live with that. Oh, okay. Duh. It really doesn't matter what the order of these pins are, does it? But I do want those to be that way. Let's do that, that, and that. Okay. And then these, 12 is going to end up connecting back to 4. I want to move all of, okay. Let's move all of this in a little bit. So it was 9, 10, and 11. Well, that's interesting. Oh, it's connected up here. Okay. I was going to say, are these only connected to a test point? That doesn't make sense, but that is not the case. All right, so 4 will sweep back down here to... I'm going to connect it to 13 because it shouldn't matter. It just makes the schematic cleaner. Nope, don't like that. Do you need to add unit C for ground in VCC2? If I was going to make a PCB, I might worry about that. But I don't know. That's a good question for the guys in chat. So like this package had 3 units. Oh, I see. So unit C is power and ground for this chip because it's a dual package. Okay. Now, for the purpose of this schematic, I'm not at all worried about that because it's just going to be implied it's connected to 5 volts. I mean, it's digital logic. What else is it going to be? All right. Yeah, so I'm having an internal mental struggle about not connecting these to the right pins because electrically these are all the same, right? So it doesn't really matter what order you put these in. But I was just thinking, no, I guess, yeah, they're electrically they're all the same. So if you try to ohm between, yeah, it doesn't matter. Because they're connected. There won't be a trace on the PCB where they're connected together, but internal to the chip, no, they're not. They're not physically connected together, but for the input of the chip, it doesn't matter because of the logic. So I don't know. I just feel like I should leave it the way that it actually is. Okay, that's cool. I didn't know about that. I was looking just to see if anything's gotten added since the last I used it. How do you add a line break? I can't remember how to do it, and I know I've done it before. Yeah, I thought I tried the shift enter. Yeah, shift enter is not working. Let me try this one. Nope. Let's try that. Okay. Okay, so shift, it really literally was shift enter, not shift return. So shift return, it didn't work. We're making a... All right, we'll do that. Now I'm satisfied. Now I'm satisfied to ignore this until later. All right. What's up here? Okay, looks like a couple of D flip-flops. All right. As doing all of these little detail, like all these little things really annoy me, so we're gonna come back when we pick this up next time. I'll probably start with those. I want to do some of the easier work for the moment. So let's see. And then I get up here and everything is just a jumble mess. All right, tell you what, I'm going to take a couple minute break. I need to grab a snack, get some water. And so tell you what, we'll throw the trivia on. Feel free to chat among yourselves in the chat, and let's do trivia for just a couple seconds while I take a break. All right, I will be right back. All right, and I am back. And I think I even remembered to unmute my microphone this time. I have not put the code for the trivia up on GitHub yet. I did actually almost think about doing that on the stream tonight, but I want to look back through it and look through the code one more time. But my plan is to put it on GitHub, so I will do that. What I still haven't quite decided is what to do about the questions, because I want to have a way for people to submit questions, but I also don't. I guess it doesn't really matter if somebody downloads all the answers. So the real problem with the questions right now is it's just a massive JSON string. So now it does turn out I have a utility that will let you decode it and see them. But what I had sort of wanted to have is like an easy way for people to submit questions. So anyway, but yeah, I will release the code for the trivia. One of the things I would really like to add support for is images, because I'd like to be able to like show a circuit or something and say, which one is correct or which one has a problem. But everything right now is text-based, and I'm not sure what's going to be involved to go that route, but I think it would be kind of cool. So the one thing that won't be in GitHub though is the image of the computer. Not a big deal, but that's a licensed image, so I can't throw that up. But that's okay. You can find your own favorite picture to use. Okay, so we've got an AM26LS32, and then it looked like a 11-pin serial connector, which I guess is this one, or I forgot to copy another one. I don't know. Let's go ahead and get these labeled up first. J15-1. Oh yeah, I'm glad I took a break. I was starting to fade out a little bit. Okay. So for those of you that have maybe just joined or joined recently, we are redrawing the schematic for the Apple II GS in KiCad. This is part of a project I called Bit Preserve, which you can find on GitHub, where people have submitted all kinds of 8-bit computers, and we're basically just recreating the schematics in a modern format. And so there's, I think there's a lot of benefits to having even old schematics in something where you can do a search or you can modify it. Like for example, we think we may have found a typo in this schematic in this schematic, and so we can get that corrected now. Although that does lead to a kind of a quandary question, which is when we find typos, do we want to document those, or do we want to have the true original schematic? And then if I was to say, go and do some board verification and realize that maybe there was a revision on the board, how do we document that? But when I first announced this project, I sort of put all of those issues on well, that'd be a nice problem to solve one day. That is a great problem for a future somebody else. All right, we need a chassis ground. These are oh, it's because it's connectors. That's why. Is there a chassis? Okay, I'll take power ground. That works. Where does 4? Okay, so 15.1, Hiska, 15.3, Japia, RxDia. So 4 comes down to, okay, so 4 is going to get connected to a bunch of other stuff and an inductor, which, middle button doesn't work there, James. You can keep trying, and eventually you'll realize it doesn't work. It's just not going to happen. So we're just going to rename this. So I need to clarify, I want the label, rename that to 4, and then we will add a adductor and put that here. And now we'll add ground to here, draw a little wire, and we'll just do one of these. And then ta-da, through the magic of labels, we now have that connected. And it looks like J2 or serial 2 is, let's see, 16.1 HSKIB. I wonder what that is. HSKIB. RXD. Okay. We're going to just relabel that one because they're all different. Nope. Yeah, middle mouse button definitely does not scroll everything. Yep, F for not scrolling everything. Uh, 15.3.4 Rixda Jupiter. Okay. What do you think an RC 4300 is? You think that's like a 4.3K resistor network? It's definitely not a battery-powered door chime. That quite certain it's not that. Okay. Let's just take out wireless from that. Probably not a carbide anything. Well, that's a bummer. What would a H designator be? Are you sure the 2GS doesn't have a door chime? Well, you know, it could be that there was a door chime, but because nobody wrote software for the 2GS, it just never got used. And so that's a really good point. RC sounds like RISC processor. Yeah. I wonder if this is like resistor capacitor. Like maybe this is like some kind of filter. Because what is this AM26L32? A quad differential? Is it a differential receiver? Oh, wait a minute. Are these these are the serial port, huh? And they use differential signaling? Or does differential mean something else on this? Okay. Yeah, how about that? Huh. Interesting. So what does this have like a typical schematic that might show a filter? Okay. What to do? The first thing is, did I already create this and I forgot? Because that would be cool. Damn, I was really hoping that was going to work. Okay. I really don't want to go create a schematic symbol right now, but I think we should. So let's do that. It could be an isolator. Yeah, it could be an isolator. I was just thinking RC because maybe it stood for like RC filter. So I'm guessing it was probably something custom that they had made because I don't see anything. So 2GS, 2GS schematic. New symbol name RC4300. It'll be an H designator, 1 per package. Yay. Okay. Let's get this here, that here. Nope, wrong one. Bummer. Oh, Windows, you're so cute when you try to be helpful. Okay, so let's see. Okay, so this looks like it's 2 packages. Oh man, how do you create a multi-part unit, or do I even want to bother? Because this goes 4, 3, 2, 9, 11, 4, 3, 2, 9, 11, 15, 14, 13, 16, 10, 15, 14, 13, 16, 10. Okay. Is there number of units? 2. Unit A, Unit B. Okay. I've never done a multi-unit part, so if I'm doing this wrong, tough. We'll just have to figure it out. Let's go background color. Best I can find is it's a MIPS processor. Yeah. Yeah, turns out. Okay, so it wasn't a doorbell after all, but it was a MIPS processor, and there's 4 of them in the Apple IIgs, and they're connected to the serial port because reasons. Because Wozniak was like, well, you know, they create enough heat that it allows the oscillators to become really stable, so it just makes sense. All right, so 6. Where do you click? Yeah, so we want 7. What's the next one? Really? So it's over typed here, and it's over typed here. So 1, 2, 3, 4, 5, 6, 7. Must be 8, 9, 10, 11, 12. Yeah, it's got to be 8. Whatever. Ah, goodness. So, question for everybody in chat. With everything going on, what are you doing for fun? Who's building something cool? Even if it's like a kit or something, I'd like to hear about it. Like, so what are you guys doing to keep yourself busy besides watching me or other amazing electronics YouTube streamers? By which I obviously mean other people, not me. All right, 15. Oh, no. That's not what I wanted. Let's go 14. I was actually thinking about, oh yeah, you mentioned the SLA printer earlier. I totally missed that. Okay, you're working on a GameCube controller input sniffer. All right, well, you might be interested in tomorrow's project. Oh, cool. The rubidium source GPS disciplining. So what kind of accuracy, is accuracy the right word? What kind of stability do you get with a rubidium source? Just by itself before you try to give it any kind of feedback. Chris has a SX64. Sorry about it, having a bad CRT. I don't know if you've seen one when the CRT works, but it's a very beautiful display. I think the SX64 is the best Commodore. It's a shame that they're so bloody expensive because everyone should have one. Come on, let's get an edit in here. So, Dr. J, you're working with a solar panel. Are you trying to do something with the Pi that it's solar powered? If so, what are you doing? 70 70 centimeter power divider. Results not as expected. I don't know why. I was just trying to picture you saying that, man. I think it'd be really funny. Oh, beautiful. Beautiful. See, it's like stuff like this where it's like, you know, okay, you run into the occasional KiCad bug, and then you get into a utility and it works just like you would hope it does, and that's what makes it fun to work with. It doesn't do everything right, but the things it does right, it does really well. Four, 3, 2, 9. Ah, did it again. 2, 9. Let's come down here. Let's go 9. Let's do this one, and that's going to be 11. I did. Oh. Tab, type, tab, type. All right. So this one's going to be 17, and it's a left. And this one's going to be 18. Ah, tab type, tab type. And this is going to be 19, 12. I feel like I'm playing golf right now. Every time I think I've got it, I realize I don't. So I don't want to overhype my plan project for tomorrow, but originally what I was going to do is, I mentioned this on Tuesday. I have that the 555 surface mount board that I streamed a couple of, I guess now it's months ago, and then I've got these big resistor and capacitor decade boxes, and I thought it'd be kind of funny to change the frequency using those, and we'll do that at some point in the next month. But instead, I wanted to do something that's easy but fun and involving a soldering iron. And so, spoiler alert, I think we're going to install a mod chip into a GameCube. And so I just think it'd be kind of fun to do something like that. I really want to get back over to the bench and do some streams over there. And so I thought that was a kind of a low hanging fruit to do that. And then that'll let us get back into doing some more advanced streams like the DIY multimeter project that I have to get back to, because I've got to finish that at some point. So yeah, we'll see. I almost bought 2 of the chips because it looks like they're just Atmel 8s, and I wondered, I'm guessing they've got to be blowing the protection bit, but it would be kind of a fun well, I guess somebody's got to have the source code for that somewhere. But if the source code's not available, it would be kind of a fun project to reverse engineer and try to understand what it's doing. But yeah, I don't normally play a lot of backup stuff, but for the GameCube, I haven't decided if I really want to collect spinning media since it has a tendency to rot. But I do have the Game Boy player adapter without the CD. And so my primary reason to mod it is so that I could play Game Boy games on my TV with the GameCube. And so I don't mind modding it for that reason. All right, let's get this back over here. And I've also got, and I was going to do these after I moved, but I think now that I'll be streaming a little bit more over the next couple weeks. A couple others that I want to do is I've got RGB mods for my NESs. I've got an RGB mod for my N64, if I can find it. I don't remember where I put that, so I want to do that. And then I also want to do a couple of screen swaps on. I've got a new screen for Game Gear, I think for Lynx, and then one for a Game Boy Advance. The problem though is I don't think I have a Game Boy Advance, so I can't do that one. I probably won't buy one until after I move. Yeah, I just want to do it for the Game Boy. I got like a great deal on a Game Boy player on eBay. I think I paid like $25 after shipping because they didn't have the CD. And I was like, okay, I can buy a mod chip for $10, blank CD, blank DVDs. The mini blank DVDs are a little more expensive than I was expecting, but even those are only a couple dollars each. So I think I'm going to be $12 in versus paying another $70 for one that came with the CD or for the DVD. And the thing that's super, super crazy, the disk image is only like a few megabytes. It's not even a lot of code. So it's just ridiculous. What really makes me mad is I had, excuse me, I had a GameCube, I had the player, I had the CD, the original box and everything, and I sold it, and I wish I never did. That was, I mean, I should have kept that, because, yeah. Anyway, anywho, yeah, I jailbroke my my Wii, and after spending about a day trying to get all the pieces together and getting that working and going, I realized I forgot how terrible Wii games are, and that nobody, there's really, with the exception of like a handful of games, like say like, I was gonna say Metroid, but no, Metroid's a GameCube game. Never mind. Yeah, it's just, in my opinion, it wasn't a very, I mean, for the time and the motion controls and all that, it was fine, and I remember having a lot of fun with it. But there's really not a lot of good games on the Wii. So a temperature controlled oscillator was that 2 times 10 to the negative 9th, and an oven is negative 10, and rubidium is a negative 11. Wow. Okay. That would be cool to do some comparisons. Hey, IoT, did you see my message about Lady Heather? Have you ever used that program with your oscillator? I was actually talking to a friend of mine, I think it was last night or Tuesday night, and he's got a GPS disciplined oscillator on his bench with a permanently mounted antenna, and he's used the Lady Heather program a few times. Oh, Metroid 3, that's right. Yeah, I actually played that for a little bit. I didn't like Metroid 3. I really did like Metroid Prime, though. That was actually the first-person shooter game that I completed, even since I was a kid, because when I was a kid, our computer couldn't run stuff like Doom or Quake, and then when I got into college, I never had time. So after college, when I got the GameCube, and then I got Metroid Prime, and I think I got a good deal on it. Like, it was like on sale because people were like, "Oh, the first-person shooter isn't going to be good." It was really good. I really enjoyed it. The second one was it was okay. But the magic was that first one. I thought they did a really good job with it. Totally captured Metroid. And then 3, I didn't like it at all. I played it a little bit and then never went back to it. The L and H on the schematic you're using may indicate a default high or low. That is absolutely my opinion as well. And I want to say, and this was probably a year ago, I was looking at something that confirmed that for me. Now I forgot what it was, but I do think it's indicating whether it's active high or low, which is originally I wasn't going to include it, and then I decided to, and I'm glad I did, because there must be a reason why they wanted to call it out. All right, let's save that. Now let's add the RC4300. Oh, look at that. It's right there. That's so convenient. All right, and that's going to be H5. And then we will add a unit B somewhere around here. And this will also be H5. Let me grab this link. So looking at the board, it looks like H5 might be one of these. Interesting. Yeah, okay. I could see that. So are these just like, or is it just like maybe like a, I'm trying to think, what would it be if it's in a package like this? I was going to say a chip inductor and chip resistor, but that wouldn't make sense. Okay, interesting. Well, this is super descriptive. Thick film molded dip. Oh, thanks. So maybe they're just resistor. Maybe it's just a resistor network then. Okay, here's what we're gonna do. I'm gonna make a note to when I H5, H6 measure to see if they are resistor networks. What we could do, I've already got my 2GS boards packed up, but I'll make this note so that when I take the board, when I'm depopulating the other chips, I'll depopulate one of these and measure it and just see if they just seem like they're resistors. And in fact, I even have a handheld LCR that I can use to verify if they have any reactance. So good find. I'm not going to try to say your name. I'm just going to call you Mid. Or, wait, is your username Mid Indian? Like, instead of Big Indian and Little Indian, you're Middle Indian? So you're thinking on the GPS oscillator, are you thinking you're just going to swap out its internal source with the rubidium source and get a benefit from that? Is that what you're thinking? Do I still have the datasheet open? Oh yeah. Oh, how about that? How about that? Yeah, that's got to be what this is. Okay. Yeah, good find. Thank you. Oh, you know what we're gonna do? Let's note this as well. I don't know how I want to document this, but let's all right, let's document it. That way, if we come back and look at it later, maybe we can figure out what that is. And then for the sake of completeness, let's go ahead and just do a quick save as. This folder looks not suspicious. I'll put it in this one. All right. So does the rubidium source, is it powered? Like, does it have its own oven, or is it a passive, type device? Okay. So let's get to the editing tools. And come on. It's not the first time you've done this. That's always good when there's a long process happening and your music stops. That's not suspicious at all. That's not a problem. Barely an inconvenience. Why is it taking so long? Okay, I don't know why you're converting to editable text. This is an image. All I wanted was to be able to draw some highlights. And if I was on a Mac, it would be really easy. I wouldn't have had to wait for anything, but that's a whole nother story. Okay, where's my highlighter? For real? Oh, whatever. Okay, so 15 connects to RxDH. 15 connects to RxD8H. But I don't have. There we go. And 14 connects to RxD8L. Okay. So actually, Dr. J, this is where I'm thinking you're right about the assertion levels, because if these really are differential signals, then it would make sense that this is basically saying the positive and negative pairs of the differential signal. What the? So there's a line that comes through here. What? What are you talking about? So 15 is RxDA. Oh. I think when I did the edit, this broke. Do you want to save changes? No. Yeah. Oh, this might not be the... Oh, here it is. Okay. Yeah. That's still going to be a pain, but at least now it looks right. So 13 is Hishka, which is making me think of the name of Quark's mother on Deep Space Nine. Although her name was Ishka, but whatever. 16 went down into Japia 8. And 10 goes to Granda. Let's go ahead and do this, 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 this. All right, let's do it. A ground power. Okay. 13, 14, and 15. Okay, those look good. Let's wire that up. Speaking of Star Trek, I have Marina Sirtis send my girlfriend a birthday message via Cameo. And how did that work out? That sounds like it would be super awesome or super awkward. All right, so 17 connects to this one. Oh. 18 is J15-3. And 19 is J15-1. It's so funny you said that. I was just about to ask you if you would care to say how much it cost. But that's cool. So how does it work? Do you do you send the message of what you want them to say? Like what's the process look like? Or do you just like fill out a form, send $100 and get back a video? Because I was actually, and then maybe if you want to explain what Cameo is, since you've used it, you actually understand it better than I do. All right. Do that. Oh, you know what I don't like? I don't like it saying ground power. It's probably fine. It just, I guess it, I don't need it to say ground either, but I'm just used to that. Oh, that's cool. I imagine some of the people that do Cameo that it's sort of a mixed bag in terms of what they would like people to do. Like, I'm sure some love the creative aspect of, oh, I get to figure out what to say. This will be so cool. And some are probably like, dude, you're paying me $100. Just tell me what to say. Because that's how I would be. It'd be like, just tell me what to say. I don't want to figure it out. Okay, and then looks like this will connect up to here. And this is going to connect to here. 14, 6, and looks like 9. Connect to ground. Copy this over to here. And then 10 goes to power. Oh, that's freaking annoying. So 15 goes to 8, or the blob formerly known as 8, or the 8 formerly known as blob, and 7 will go to 5. And then that leaves this to come back up to power. And we're back to a ugly mess again, but tough. We'll just live with it this time. And we're going to move this over here, move this over here. I want to move this up. Nope. Nope. Okay. All right, let's get this last one done, and then I think I'm going to be done for a little bit. So we'll do, let's move this up, because it looks like a couple of these are straight across. Do this one, no connect, this one up to here, and then no connect, no connect. And then this goes to VCC. And we'll connect that and go, yay. Okay. All right. All right. That's all I feel like doing for now. Oh. I'll be interested to see what the log says, cause the moderation. Yesterday, I think it was Tizboyo or Moldavia said 3 5s, and for some reason that did it, and I don't know why. We needed to get to do a 4-channel benchtop oscilloscope shootout. I've got something in mind. I was thinking about this because I have a couple of old analog scopes, a couple, at least one. I have a couple of older digital scopes and my new one. And I was actually thinking about, what if we talk about why you would buy one or the other? Because I think I still encounter a few people who are ask me, they'll actually ask, should I spend $300 on a Regal or $300 on a really good used, like older tech or something like that? Or should I buy an analog because someone told them that analog is better? And so I would like to do something where we actually sort of look at, like, okay, I've got something in mind, so I'll leave it at that. Okay, I'm going to start wrapping up. Once again, I want to thank everybody in the chat that helped out. This was really fun. I am planning to, so I'm planning to stream Friday night and then either Saturday or Sunday during the day in the morning. I'm not sure which day yet, probably Sunday. And like I said, at least the next couple of streams, I'll be at the bench. So we're going to get away from KiCad for a little bit and we'll start doing some actual like circuit stuff. So tomorrow I think is going to be modding a GameCube. And then I've got a couple of things that I need to build and test. And at some point, I want to sit down and do a nano VNA versus my actual VNA to see how the two correlate in terms of measurements. So I'm thinking we might get to that in the next week or so. So I think that'll be a lot of fun. As always, if you'd like to keep the conversation going, head over, you sound like a boomer for a second. Type www.addohms.com/discord into your web browser. You may use Internet Explorer, Netscape Navigator, or even the new Mozilla. What was Firefox called before Firefox? Anyway, was it just Mozilla? Anyway, so if you go to addohms.com/discord, that'll redirect you to our Discord server where we can keep the conversation going. And again, I want to thank everybody. And if you're on Twitch, I'm going to send you to someone if anyone's doing engineering stuff or science stuff. So I'll send you over there. All right. Thank you, everybody. If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon.